Okay, welcome back. We're going to do some problem solving with the cosine rule. So I'm just drawing up some things here. Just a quick reminder that the angle A formula after analyzing and rearranging the cosine rule. So the cosine rule is that A squared, and you could use any side, but in relation to its opposite number, A squared is equal to B squared plus C squared. That's what the old Pythagoras rule, plus a correcting factor of 2bc times the cos of A. So that's why it's called the cosine rule. But that's great. You can just basically think like that if you want to solve a side. Or, sorry, if you want to solve a side, you might want to take the square root. Literally, as in mathematically, before you start. So you want to fill into this for a side. Because of course, if you have the square, you also have the actual root of the square by just taking the root. But more, and then the other formula you want is down here. And remember, this is going to be an inverse cos. So this has a cos in it, the direct application of the cosine rule. And if you're extracting that angle there, it'll look more like it'll be an inverse cosine. And I've done the derivation of this on a previous thing. So the A is going to appear at the end. So you want to start off with those other letters. B squared plus C squared minus A squared. All over 2bc. And that'll do us there. So we'll just keep that in mind. I might drop it in again to remind you of what's going on. So let's have a quick look at question 16 here. And if you want a page number for this, your book, cosine rule starts on page 296. It's done very well in your book, and that proof I've just shown you is done pretty much the exact same as I've shown you in the previous video. So if you follow your book along there, it'll give you a nice typed out record of what I just showed you, especially on 297. So the examples are very good in the book, they're done nicely. But of course, when push comes to shove, you want to see how we use our calculator and what the real process is like. And 298 is what we're on right now, here. Okay, so let's get down to it. And I'll just show you how it's done. Okay, so from reading the problem, from extracting the important information. So the minute I see MNP, I go MNP. And just draw up a generic triangle, just big enough to draw it right in angles. MN is 7, MP is 5, and we have a 63 degree at M. Now that's the hallmark of when you want to use the cosine rules. The most general question here is find that side there. Okay, which is probably what they're asking us. Calculate NP. So I don't want to call it NP all the time. It's opposite M, so I'm going to call it little m. So little m equals, so we want to go straight in with the correct formula. Okay, and really these are so similar, there's probably no need to write that one. Okay, so we go straight in with the formula for what we were asked for, not something related to it like m squared. So this is how it's actually being applied. You are doing the square of this plus the square of this minus 2 times their cross product times the cos of the included angle. Okay? Literally just plugging it in and away we go. 7 squared plus 5 squared minus, if you don't mind I'll say 70 there, times the cos of 63. Am I absolutely sure 10 times 7 is 70? I got a negative there, that'll do. That's okay. And boom. Okay, giving me equals 6.497. Now I'm going to do two things. I'm going to store that. Well, look, I have an m on the calculator, so I'll store it to m. And I'll also check if I'm going to lose marks to two significant figures. And I hate to look at this and breaking it to two significant figures, so let's go to the fixie option here. in number 3 and fix to 2 decimal places and hit the SD button, and the answer is 6.5. Okay, that's M. Okay, moving to question 2. Oh, we have a drawing. How nice. And it's exactly what we expect to see for a cosine question. 12 here, 17 here, 71 degrees here. So if it's the most basic type of question, they'll be asking for this. And I haven't written any letters down yet. I hate that. AB is 12. So just on that, you know, we really have to get the speed of this. Sometimes it goes a long way around, but if algorithm is kept, if there's a fixed algorithm, it's very quick. So I really think it's a disadvantage almost to have the diagram, so I'm going to cover it up and ignore it. I'd rather go by this information, because once you have your algorithm down, the information is actually great. So basically you write the letters first in any particular way at all. You put in your triangle, and then you start filling in the information based on that AB is 12, which is really C as far as we're concerned. BC is 17, and the angle at B is 71. I prefer that. Now calculate AC basically means calculate B, and I don't want to be, so I'm just happier now. So calculate this B. So B, so you can drop their notation and use yours. It's far better this way. So this is equal to the square root of 12 squared plus 6 squared minus twice 6 by 12 by the cos of 71 degrees. So get to know your way around. Square root 12 squared. Just get some bit of muscle memory on where things go here. Remember, you're kicking off with a plus, then you're moving to your square plus a square, then to a minus, then to filling in a pile of numbers. Now you might want to push this along, 12 12s. Yeah, that's 144, but you may not. Just be very careful about that. Cos of 71. Getting 11.54. Okay. Question 3. Okay, great. We've got something with a PQR in it. PQR in it. We got the P to Q is 8. The Q to R is 7 centimeters. And at an angle at Q is 33 degrees. Find this. Find Q. Q equals the square root of, this needs to be very long. Okay. 8 squared plus 7 squared minus 2 times 8 times 7 times the cosine of 33 degrees. Root 8 squared plus 7 squared. Okay, I don't know what 7/16 is, but as I'm calling that 16 though, just means, so minus 7 by 16 by the cos of 33. Like Amplet, I just want to see what happens when I don't close it. Oh, okay, you know now. Square root of 8 squared plus 7 squared minus 16 by 7. Like Amble, what did I do last time? I didn't close it. But yeah, I'm okay with putting the cost there. I just didn't close the argument bracket. So there's your argument bracket closed. And we get equals 4.37. Remember, it's in centimeters. Okay, these are straightforward applications. Moving on now to question 4. So don't consider a drawing a massive advantage if you can just take it from what I'm doing. You can bypass that illustration of it and use the algebraic approach quicker. Well, you draw it, but you draw it in a way that's not aligned with their drawing. Okay. So looking at question 4, I got QPR, QP and R. I got 143 degrees at P. Okay, come on. I got 143 degrees at P. I got P to Q to R. I got PQ is 25. I got PR is 40 centimeters. And presumably we're looking for this. Find this, which is little p. Okay. So we know it'll be bigger than 40 and less than 65. So that's a nice little prediction. First of all, will it be bigger than 40? Of course it will. Bigger than 40 and less than 65. So that'll help. So off we go. You can go ahead and you'll get it after a while. You'll get fed up putting it here and in a calculator, but just be careful in the exam. So you have 40 squared plus 25 squared minus 2. Be very careful about that 2 and this minus. Okay, and plus minus. Just get used to this. 25 by 40 by the cosine of the included angle. Okay. Square root of 40 squared plus 25 squared minus 50 by 40 by the cos of 143, close up that argument bracket, and we get 61.82. Sanity check. Whoa. Yeah, it's in where we expected it to be, and it's in centimeters. Okay, that's great. We're moving to question 5, and we're trying to pick up the pace. 5, a PQR. Let's see, do they give us any huge angle? Oh, this one we need the angle. Lovely. Okay, so PQR, P, Q, and R. PQR. So P to Q is 4. Q to R is 3. And PR is 6. So one thing is they're in centimeters, absolutely irrelevant as long as they're all the same unit, so we won't bother. So if there's the 3 lengths, you can leave out the units, it's irrelevant. It doesn't matter what the units are, because we're talking about similar triangles. Okay, so we do need to know what letter, which one they want us to get. Sometimes they say the biggest and the smallest. This would be the biggest angle, this would be the smallest angle, and this would be the one in the middle. So they can ask you any of those things, because that theorem is on your course. But so, question 5. Find the angle at P. Okay. So I say that angle P is equal to the inverse cos of, now when it comes to the odd one out, the guy opposite you is the odd one out. So this is how the application goes. Of course we can, I promised you I'd drop this in, and of course you can talk about, hey, if I want an angle, I'm going to do an inverse cos of the flanking sides, the guys that are the sides that are the arms of the angle itself, squared and squared, minus the opposite side. Okay, so while we're operating on this, we're talking about 4 squared plus 6 squared minus 3 squared over 2 times that by that. Okay, plug it. There's only one answer, always only one answer here. Lovely stuff. Okay, so plug away. Shift cosine fraction bar, get used to it. 4 squared plus 6 squared. I wouldn't bother doing any mental maths, not worth it. Minus 3 squared down. I'll do 60. Come on, it's 48. Okay, we'll do 48. I just said generally, unless you can do all the maths in one section, But yes, we can do the maths here. That's 8, 6 8's 48. Okay, that's cool. It's up to you. You can plug it in if you like that, depending on where you are with your mental maths. And that comes out, remember, we're rounding to 2 decimal places. And generally when you're doing your homework, really I wouldn't bother with worrying about it. Just in a situation like this, it might be nice to just fix your calculator. That was an angle. There we go. Okay. By the way, we did note it would be an acute angle. And we did note it was the smallest of 3 angles, so we knew it was less than 60 degrees. Okay, so that passes the sanity check. Question 5. Okay, question 6. Question 6. I'll just zoom in for a minute, and that's all the way back. No, it ain't. Anyway, zoom in on it. So we've MN and P. M. That's all I see first. I get that down. M, N, and P. MN is 12. NP is 18. And MP is 23. Find the angle at N. Okay, so we'll go a little bit quicker now. The angle at N equals the inverse cosine of 12 squared plus 18 squared minus 23 squared over 2 times 12 times 18 times the... What am I talking about here? There's no cost there. What am I talking about? That's interesting what just happened. Oh, you can't even see what I'm doing. Maybe that's a good thing. Because I have often, when you're writing it, I said that's interesting because when you're writing it this way, you're going double that by the cos of the angle, and I just went into autopilot there, as we sometimes do, and that's fantastic.